Assalamu alaikum students. 12th standard Computer Applications Lesson 11 Network Examples and Protocols Part 2. Hi students, welcome back. This class is a continuation of previous session. In the previous session, we have seen the following topics: data communication, types of networking protocols, internet, intranet and extranet. The last one, mobile networks, that is generation of mobile networks. And today we are going to see about three topics: WLAN 802.11, that is wireless local area networks 802.11. The next one, RFID, that is radio frequency identification. And the last one is OSI, TCP, IP and other network protocols. And today we will be seeing about these three topics. Okay, so the first topic is WLAN 802.11. WLAN is nothing but wireless local area network. About this you have already studied in 11th standard, and again in standard 12 they have given a glimpse of it. Okay, so WLAN stands for wireless local area network, that is connecting electronic devices in a smaller area without wire is called WLAN, that is wireless local area network. Okay, this is possible using a technology called Wi-Fi. The full form of Wi-Fi is wireless fidelity. Fidelity means connectivity. So this is wireless fidelity. And the protocol used in this technique is 802.11. What is the protocol used in this technique? The protocol is 802.11. So Wi-Fi is a wireless network technology that permits computers and other alternative devices to be connected to every alternative interlocal area network onto the net without wires and cables. Let us see the advantages and benefits of Wi-Fi. First point, it provides mobility. For example, if I get internet wireless connection through my laptop computer at home and at work, because of Wi-Fi or hotspots, both at home and at work, I can continue my work in wherever I am. That is called mobility. Okay. Second point is it provides connections to the internet. You all know well about how to give internet connection through Wi-Fi or hotspot to your mobiles. And third point is flexibility of LAN, which means it provides all the features of LAN. Not only computer, all the electronic devices can be connected using this Wi-Fi. Ensures connectivity. You can connect all the electronic devices in the small local area network. Okay. Next one is it allows places that are remote to benefit from connectivity. The next one is low cost and high benefits. The cost involved in this is very less. Okay, suppose if you want to have a LAN, wired LAN, you need to buy wires, you need to buy routers, so many things. It costs too much. So Wi-Fi is a small device, you can buy it within 1000 or 2000. So cost wise very less, but we have more benefits. That is benefits wise very large, very high. That is low cost and high benefits. So these are the advantages or the benefits of Wi-Fi. Next we will see about the RFID. RFID stands for Radio Frequency Identification. RFID uses RF wireless technology to identify the object. So what is the full form of RFID? Radio Frequency Identification. The main components involved in the RFID technology is RFID tag, a reader and a computer. So these are the three components involved in a RFID technology. I will show you that what is RFID tag. So this is RFID tag and this is the RFID reader. And you all know about that what is a computer. Now let us see what is the use of RFID, what RFID works and how it works. The RFID tag will have a chip inside it which can send and receive the signals, and this tag will be placed on any object. It can be anything. For example, let us take it as a bus. This RFID tag can be placed it on a bus, and this reader will have a small antenna to send and receive the signals. Let us place this RFID tag on a bus and this reader on a bus stop. Okay. So what this antenna will do is it will send signal to this tag, and this antenna and the tag can be at distance. It cannot be, that is, it need not be close to each other. It can be far away places. So what will happen is the reader will give a signal to the object and identify where the object is and get the signals from there, and that signals it will send it to your computer, and that computer will analyze it and do whatever we want. So this is how we can identify where the objects are exactly. This reader in the bus stop can identify where the bus is, and it can send the signals to the computer or a computer program attached to it. So that programmer will display the bus is arriving. The bus will arrive in 5 minutes or 10 minutes. It is here in this place. So get ready the passenger. Like this will display the message on the screen. This is called as RFID technology. There are two types of RFID tags: active RFID and passive RFID. Passive RFID tag will be used the reader radio wave energy to relay its stored information back to the reader, because this tag does not have own power source. So it has to get the power from reader antenna to the tag antenna. Next one is active RFID tag. This is a battery powered RFID tag is installed with small battery that powers the broadcast of information. Main components of RFID system. First one, a RFID tag. Next one, a reader. Third one, a controller, that is a host computer. RFID tag. It has a silicon microchip attached to a small antenna and mounted on a substrate. Okay. So RFID tag, this is RFID tag. It has a silicon microchip that is attached to the small antenna and mounted on a substrate. Next one, this is a reader. It has a scanner with antennas to transmit and receive signals used for communication. So for communication, using this reader, we can send and receive the signals. Next one is a controller. Controller is nothing but a computer. It is the host computer with a microprocessor which receives the reader input and processes the data. So while communication, the reader receives the signals and pass it to the computer. So the computer has to analyze it. So now here the two types of RFID system is again active RFID system and passive RFID system. Active RFID system, the tag has its own power source. So active RFID system has own power source. So these systems used for larger distances and to track high value goods like vehicles. Now we are going to see about very important question in this lesson, that is Osa Reference Model. Osa stands for Open System Interconnection, and this model was found in the year 1934. We will see the outcome of this topic. Upon the completion of this topic, the learner will be able to understand the Osa Reference Model and also list various layers in the Osa Reference Model and to understand how each layers interact with other layers. Before we start, we will see what is layering. Layering means decomposing the problem of building a computer network into more manageable components, and we call these manageable components as layers. So the problem of building a network is a big one, so we are decomposing that into smaller ones, which we call as layers. We have two benefits. One is it provides modular design, and the second one is it is easy to troubleshoot. We will move on to the purpose of OSA model. The purpose of OSA model is to facilitate communication between two systems. When I say two systems, it means two different systems without requiring changes to the logic of the underlying hardware and software. I will elaborate it now. We are going to establishing communication between two different systems. Two different systems means two different computers with two different OSs, even two different devices with two different functionalities. So, in terms of hardware also it may be different, in terms of software also it may be different. So, two different systems are going to communicate with each other with the help of guidelines provided by the OSA model, so that we don't require any changes to the logic of the underlying hardware and software. Now we will see what are the various layers in the Osa reference model. Basically, there are 7 layers in Osa reference model: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. As per the Osa reference model is concerned, the order of the layers are very important. So, we should not change the order of the layers. It is very important for your examination also. So, order of the layer also very important. Let us see once more the order of the layer: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Now we will see how each layer interact with other layer. In this scenario, there are two devices, device A and device B. And these two devices are connected to a network, and there are some intermediate nodes. This is a router and this is also a router. When this data wants to move from this computer to this computer, so the data whatever this computer is generating has to be placed on this link or this line or this cable. So before placing onto this cable, it has to go through all these 7 layers, and finally this physical layer only places the data on the cable. User who is sitting in this place open an application, and that application only going to generate the data. The data generated by the application layer is handed over to the presentation layer, and then the presentation layer hands over the data to the session layer. Then comes the very important layer, transport layer, and then the data is hands over to the transport layer. After the transport layer, and then the data is hands over to the network layer. Then it is given to the data link layer, and finally the data goes to the physical layer. If you observe, each layer has its own set of functionalities. In the layer 7, layer 6 and layer 5, that is application layer, presentation layer and session layer, the data will be called as data. In the 4th layer, that is transport layer, the data will be called as segment. In the network layer, the data will be called as packet. And the data link layer, the data will be called as frame. And the physical layer, the data will be called as bits, that is zeros and ones. And the flow of data will be application layer to physical layer, application layer, then presentation, then session layer, then transport layer, then network layer, then data link layer, and then to physical layer. For example, if you send an email, that email will be sent from the system. That email will be considered as a message or data. That is nothing but application layer. So, email services in the application layer. Here, the data will be in the form of message or data. Then the data will be sent to the presentation layer. Here, the data will be encrypted in the form of security purpose. Encrypted means the data will be converted as a code or some other symbols which cannot be understood by the others. That is called encryption. So, that complete process will be done in presentation layer. Then the data will send to the session layer. Here, some checkpoints will be created. In the session layer, we'll start the session between your computer and the server computer. Then the data will be sent to the transport layer. Here the data will be called as segments. So the data is divided into number of smaller segments, and every segments there will be one sequence number. Along with the port address will be added for each and every segments, and it will be transmitted to the destination, and then the segments will be sent to the network layer. Here the IP address will be added as a header to the given data. Both the sender IP address and the receiver IP address will be attached here. So IP address, port address and data will send to the data link layer. Here it guarantees that the data transmitted are free of errors. This layer uses the protocols like 802.3 for wired network, that is cable network, and 802.11 for Wi-Fi, that is wireless network. Then the data will send to the physical layer. Here the entire data will be changed as bits, that is zeros and ones, and then this encoded data will be transmitted to the other side of the network or to the destination computer. And this physical layer knows which kind of physical medium which is connected to receive the data in the form of zeros and ones, and then pass to the data link layer. Here it will check the data transmitted is whether free of errors or not. Here everything will be checked, and then the received data will be passed on to the network layer. Here the IP address will be checked and the other routes will be checked. Then it will pass to the transport layer. Transport layer will receive the data and it will check whether all the segments are received or not. Then the received data will be passed on to session layer. In the session layer, it will receive the data and pass to the presentation layer. In the presentation layer, decryption process will be done. Decryption means in the sender side, we encrypted the data, right? Encrypted means the original data will be changed as some code or some symbols. So that encrypted data will decrypted here. Decrypted means it will automatically changes to original data. After the decrypted process overs, then the data will pass to application layer. So application layer acts as a user interface platform comprising of software within the system. Finally, the receiver in the device B receives the data. So this is how the OSI layer works. Our next topic is TCP/IP, that is Transmission Control Protocol or Internet Protocol. This is also very important topic in computer network. So in this chapter you can expect either OSI layer, that is OSI Reference Model question or TCP/IP question in your public examination. TCP/IP. TCP/IP is a set of protocols, not only a single protocol, it is a set of protocols which governs communication among all computers on the internet. So, TCP/IP protocol tells how information should be packaged, sent and received as well as how to get to its destination. TCP/IP working. TCP/IP is a combination of two protocols. One is Transmission Control Protocol and the other one is Internet Protocol. Transmission Control Protocol provides reliable connection-oriented transmission between two hosts, which means while the data is transmitted between two computers, it provides the guarantee, the trustworthy transmission of data. And also it sees that the packets for errors and submits the request for retransmission in case any of the packets are missing. The next one is Internet Protocol. Internet Protocol which uses IP addresses to deliver the packets. It is an unreliable protocol, whereas TCP is a reliable protocol. The IP protocol does not guarantee delivery of information, whereas the TCP protocol, it guarantees the delivery of information. Next one is frequent TCP/IP protocols. So frequently these protocols were used in TCP/IP, HTTP, HTTPS and FTP. So HTTP is a hypertext transfer protocol. It is used between a web client and a web server and it guarantees non-secure data transmission. Here there is no guarantee for the data transmission, whether the receiver receives the data or not, there is no guarantee. In HTTPS, it is used between a web client and a web server, ensures secure data transmission. Okay, here it provides secure data transmission because the full form of HTTPS is Hypertext Transfer Protocol Secure. So it provides a guarantee for the data transmission. The next one is FTP, that is File Transfer Protocol. It is used between computers for sending and receiving the file. Domain names and TCP/IP address. We have already known what is IP address. IP address means it is a logical address used to uniquely identify a computer over the network. Okay, so in the network, each and every computer has unique address. For example, the IP address for Google is 216.58.216.164. So these are numbers. These numbers are not easy as to remember. So the domain names are used instead. So the domain name for Google is google.com. It is easy to remember, right? Now let us see what is the difference between Osa Reference Model versus TCP/IP model. Osa is just a reference model, whereas TCP/IP is a implementation of Osa model. Osa Reference Model has 7 layers, whereas the TCP/IP model has 4 layers. The 7 layers of Osa Reference Model are application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer, whereas the 4 layers of TCP/IP model are application layer, transport layer, internet layer and network access layer. The application layer of the TCP/IP model is similar to the session, presentation and application layer of the Osa Reference Model. Transport layer is as usual transport layer and the internet layer which is equivalent to the network layer of Osa model. Network access layer in the TCP/IP model combine the two layers, that is data link layer and the physical layer. So this is the TCP/IP model and this is the Osa Reference Model. The implementation of Osa model is TCP/IP model. Now we will see one layer after another. Let us start with the lower layer, that is network interface layer. Network interface layer. It is the bottommost level layer. It is the combination of two layers, that is physical layer and data link layer. It is used for physical transmission of data. This layer is also responsible for defining a protocol. Protocol means set of rules to be followed to connect hosts. Different TCP/IP protocols used in these layers are Ethernet, Token Ring, and other link layer protocols. And Ethernet and Token Ring protocols for local area networks, that is wired network, and for the wireless networks it uses the protocols such as X.25 frame relay and ATM for wide area networks. So for wired network it uses the protocols as Ethernet and Token Ring, and for a wireless network it uses X.25 frame relay, etc. The next layer is network layer. It is the layer where the data is addressed, packaged, and routed among networks. The different protocols used in this network layer are IP, that is Internet Protocol. It is a routable protocol which uses IP addresses to deliver packets. It is an unreliable protocol. It does not guarantee delivery of information. The protocol is ARP, that is Address Resolution Protocol. It resolves IP addresses to MAC. MAC means Medium Access Control Addresses. Okay, Medium Access Control Addresses. A MAC address is a hardware identification number. Hardware means a computer or any other devices. Okay, that identification number that uniquely identifies each device on a network. That is to map IP network addresses to the hardware addresses. The next protocol is ICMP, that is Internet Control Message Protocol. This protocol is used by the network devices to send error message. For example, the user wants to connect with the server machine. That time the server was so busy. So using this protocol we can give the error message, that is server is so busy. So like this type of error message will be given using this protocol. The next one is IGMP, Internet Group Management Protocol. It is a communication protocol used by host and the routers to send multicast group communication message to multiple IP addresses at once. For example, one message sent to multiple users. So this type of group communication messages will be maintained by IGMP. Next layer is transport layer. This layer guarantees the transportation or sending of data is successful. Two main protocols used in this layer is TCP and UDP. So TCP is the Transmission Control Protocol. It provides reliable connection oriented transmission between two hosts. It ensures the delivery of packets between the two hosts. The next one is UDP, that is User Datagram Protocol. It provides connectionless and reliable one-to-one or one-to-many delivery. The next layer is application layer. The application layer of the TCP/IP model is similar to the session, presentation and application layer of the Osa Reference Model. The protocols used in this layer is HTTP, FTP, Telnet, SMTP and DMS. So HTTP means Hypertext Transfer Protocol. It will be used for World Wide Web. It is used between a web client and a web server and it guarantees non-secure data transmission. The next one is FTP, that is File Transfer Protocols. It enables a client to send and receive complete files from the server. Next one is Telnet Protocol. It connects to another computer on the internet. It is used for connection purpose. Next one is SMTP, that is Simple Mail Transfer Protocol. It used for providing email services. So using this protocol we can transfer the emails. The last protocol is DNS, that is Domain Name System. It is very tough to identify the IP number. So it provides the domain name to the IP address. The address for any website is not easy to remember. Domain names are used instead. Google. The IP address for Google is 216.58.216.164. It is not easy for the user to remember these numbers. Instead of that, we can use the domain name. The domain name for Google is google.com. So these are the protocols used in the application layer. Students, this lesson ends here. I hope you understand this lesson. The assignment of this lesson is discuss about OSI model with its layers. Write neatly and submit your assignment on time. Thank you for watching this video. We'll see you in the next video class. Assalamu alaikum.